Nice to see you again. So we see again in May this year, 2023. So let's focus on picture quality, and then in the first step, let's start what kind of content we have, and then what kind of content comes to our products. So in general, today you see that we are switching to streaming, and streaming is primary source of the content. But even if you look on streaming, and for example on Netflix, you will see that only 10% of people have highest subscription tier of Netflix. Most of them use Netflix in HD SDR, so SDR is still important and upscaling is still important. Then you have HDMI source as set-top boxes, also a big group of people. In this case, HLG in Germany or in UK is also important factor. And then we have DVB, we have gaming, and also Blu-ray, but Blu-ray is total niche product right now. And the source, but still you have Blu-ray discs, and then we know that it is the top-end quality in terms of content. But anyway, if we move from the content source and the way how we consume the content, then we move to what is key to create product. So you see it on the right side that we talk about Dolby Vision, HDR Performance, we talk about also peak brightness, input lag for gaming, and also upscaling. So in this case, we come to the point why TCL is focusing on Mini-LED technology. Then from premium perspective, if you want to create premium product, we have 5 major pillars. We have clarity, contrast, color, motion, and screen. And today I will focus step by step on these areas. So starting from clarity, first point is upscaling. As we said, HD is still the source. In some cases, is also SD as a source of the content. So AI, deep learning, in this case, we just use details from the real world, and then it's not anymore SR from the past, which is not very sharp, but AI approach. Another one is content classification. In this case, we have to recognize the type of the content which is coming to the TV set, and we adapt settings. Another point, the contour, which is crucial for heavily compressed content. We can also show you on one test sequence how the contour works. And then separation of the foreground and background, so then we can apply different settings to the face and different settings to the background. But then you can raise the question, is it already done, or we still we have bright future for AI in products? So I think there are still 4 major areas we will see AI improving picture quality. And then in the first step, adaptive settings, we can have more and more scenarios for this adaptive settings. With adaptive settings, by separation foreground and background, we can also create the feeling of depth of the picture, because we have different processing for both of them. Then the interlacing still is a story, because you have 1080i as an input from set-top boxes, and it will help. Another one is upscaling, so from spatial to temporal, so we can inject more details from frames which are before, and then that's why you have a feeling of more natural picture. And then motion is another area where AI will help, because then by training algorithms on the real sequences, we can avoid halo effect. So contrast, and then we talk about Mini-LED story. Again, 5 major areas we recognize and we master. So the first one is processing and how we drive the backlight. Another one is Mini-LED backlight and the way how we design. And this year we have many improvements over past year. You have also saw that we have a special demo for you to show you how it works with all the details. You can just look into the TV set, how it is designed. Quantum dot enhancement film, we have it also, we can show you how it works. And then VA panel, another important part, because here we have, it's responsible for the motion, viewing angle, and also native contrast. And then anti-reflection coating, which is important for no rainbow effect. So what we did this year for Mini LED, and what are the principles of the design. So first point is optical distance. So then you know that in Mini LED we can play with the optical distance, so the distance between LEDs and the LCD screen which is in front. More distance we have, less LEDs we can use. But closer we are, we need more LEDs, and then we can have more zones. But another point is to be able to distribute the light equally, and then to be sure that everything, the distribution is always correct for the zone. Then, okay, number of zones. 2 years ago we started from 100 something, but we see that we have to increase number of zones, and then I will also show you maths behind this number of zones. And the last thing is fast response time. So you know this test pattern, and then on some products you see motion trail, so it's very long. And in our products you don't see it. So this year what we did, we have new LEDs, so we call it triple TN junction. So like we put one LED, 3 LEDs inside, so it is more efficient and also brighter. So you see this brightness difference. Then there is also improvement related to the material of the lens, because on each LED we have to put the lens if we want to make the light uniform. We also do corrections by zone, so it means that we can correct each zone during production to be sure that the backlight is uniform. And the last thing, last year we started from 12-bit driving of the backlight, but the challenge was to make it linear, and then linear driving is another challenge to be sure that we can split management of dynamic range between the screen and the backlight. So let's go to the maths, and then how it looks and how interesting it is. So first step, okay, this is the input. So we have PQEOTF, which is 27 steps of dynamic range. You can calculate it easily. From the darkest area to the brightest 10,000 nits area. Then we have processing of inside the TV set. For the time being, it is in all the products limited to 24 stops, because we have to do it in power low, and power low 10 bits anyway, mathematically 24 stops, no way to make it to go wider. And then in the second step and the last step, we split it to the screen, and also we split it to the backlight. Then let's go deeper to this drawing, and then to see how this APL curve, which you see in red, is driving the brightness according to the APL. Which APL, like movie, TV program, game, is where, and then what it means that if we want to move to left side, to your left side, so as you see this dotted one, so in this case we can have more dimming zones. And then this is purely linked, so less zones we move to the right with the curve, more zones we move to the left. But another point is blooming suppression. This is another trade-off we have to do, because if we don't make the curve this way, but we will try to start on the higher level, so then immediately you see blooming. And then we come to the point, does it make sense or not? So in the green you see dynamic range. So by, let's say, moving this curve to this side, we have slight impact of dynamic range, but anyway it is still above of what your eye can perceive, and even you have very large screen, if you put your eye to the left or to the right, still you see very high dynamic range. And then on the right side you have comparison between technologies, between Mini LED and the same price OLED. I want to always highlight same price, because you can take the most expensive OLED right now, which is doing 1,500 nits and so on. But we don't compete with this OLED. We will have new products in the future, and then we will come with revised story. Right now, C84 is just addressing the price point, which is not the top-end OLED product. So the demo we have in the second room more or less will cover for you how it works, and then what are the LEDs, and then how to compare it with global dimming product. So global dimming, then we have mini LED, and you see over there if we have thousands of zones, so it looks this way. As I said, we have diffuser, we have all the parts for you. We can put it on the screen, and then you will see how the light is changing from the zones through the diffuser, then going through quantum dot enhancement film, and then finally ending up with optical sheet in front. But what I said also is the power of the brightness of MiniLED for living room. So again, we come to this comparison, and then you can take it in bright room, dark room, for mini LED and for OLED. And we have also with us the product, which is same price. We can put it also side by side, and then with different content you can assess it. More interesting is that we have purpose-made content, which was graded for very high average brightness and low average brightness. And then if we do it for high average brightness, you will immediately see the difference that OLED is unable to deliver enough of energy. If we do it, if we grade this for dark, so then you will see that it will look quite similar as long as we don't use Dolby Vision IQ, which is pushing the brightness up. So generally, in simple words, you can have today even three technologies for your living room. You have emissive technology, which is today OLED. You have transmissive, which is mini LED. Why transmissive? Because we create light behind, and then light is going through LCD screen, and then you have reflective. So we have triple laser beamer for you also to compare it with a 98-inch TV set. And then that's all about contrast. So let's look on the color. So what is key with color, and especially with color volume today, is that streaming has completely changed the amount of information your TV set is getting. So in the past, it was generally even HD TV as SDR with very limited amount of brightness information and color information. So Netflix with Dolby Vision completely changed it. So you can get content which is graded up to 4,000 nits, and then which is DCI-P3. And that's why mini LED again is the solution, able only to meet these requirements in terms of brightness, also in terms of color. And then we have two color solutions. So we have one which is for mini LED based on quantum dot enhancement film, and another one is based on RG LEDs together with gray quantum dot. Last point is blue light filter. More I have it close to product, so to show you how it works and how it is changing. But when you look on the comparison of these four different color technologies we use in our products and you can have on the market, so you see that you have sRGB, so standard TV sets. Then you have white color gamut. Then we have QLED, which is based on also white color gamut, but with addition of the green layer. And then on the right side, you have the spectral power of quantum dot enhancement film, which is used in mini LED. So we covered clarity, contrast, color. So then let's look on motion. So you ask for a lot of details, so you have all the details, how it works in the TV set, what kind of content can come to the TV set. So you see that today we have 4 different input scenarios for signals. We can have 25, 50, 100 hertz. We can have 24, 30, 60, and then 120. You have a lot of different combinations we can put on the input to the TV set, and then finally ending up with HDMI VRR. And then in case VRR, so you see the content is going directly to the panel, and then it can go from 48 hertz up to 144 in UHD, but in Full HD we can also reach 240. Today we do it as 4K 1K. 4K 1K means that we have Full HD content coming to the TV set, and then the content is sent the lines are sent, and then scaling is done by the panel. So you don't have the effect of last or basic products with, for example, if you have 60 Hz UHD with 120 Full HD, you have line doubling, and then the picture lines are not smooth because you will have always steps. In this case, we do line averaging. So, but if you have the case of standard content, video content, you can also use 240 Hz or 200 Hz. We call it motion acceleration. So in this case, UHD content, we interpolate frames to 240, and then we do line averaging. Also, if you want to have it, so then we can show you. But in most of the cases, it works in 100 or up to 120 Hertz. And then there is also a question if 144 can be interpolated. No, 144 cannot be interpolated. 144 is only for this direct PC connection. Then the question is, why you have so many native 100 Hz and 120 Hz products if you are always told that 24p is the best motion performance. But the point is that 24p is a very good story as long as you don't have very high brightness. If you have very high peak brightness and you sit very close to the screen, you start to discover that it is extremely annoying. So either you have to dim the brightness or you have to create more frames. So that's why you will have more and more products having 120 or even more hertz. You have also Hollywood working, the story of TrueCut to deliver the content in 48 frames. But they have to deliver in a way that they can manage the judder, because if you see it without judder, so it becomes very strange. It's not like Hollywood feeling. So, but it will, I think, come sooner or later to our products. Then last point is screen. With screen we also work, and then starting from the pixel design, so 8 domain for wide viewing angle. Then we don't want to use any specific film addition to make even viewing angle wider in LCD, because it impacts screen efficiency, so light efficiency. It also has this side effect of a rainbow effect if it is done together with anti-reflection. So we have slightly different approach. I think still very good, because you noticed last year this anti-reflection improvement. Then the Mura story implemented last year, but it is technically called by you dirty screen effect. So when camera is panning, in the past you were seeing a strange background behind the picture. So this strange background was linked to the Mura, in fact, that pixels were unable to display correctly the brightness. So each pixel have slightly different brightness. So right now all the panels we produce in CSOT get this Demura treatment, and the information is sent to the factory and put to the platform, so correction is done. Why it cannot be done during panel production? Because we don't use timing controller. Timing controller is already part of the platform, and that's why we have to do it during production. The last thing, two things are panel and uniformity. So uniformity is still the story for gray and white, which is important. And panels, we don't use any IPS panels, only VA panels. Then let's look on the signals we can have today in our products. You see that there are a lot of them, but generally you get SDR 8 bits, which has very limited dynamic range, which is losing a lot of dark and bright details. And then moving to this direction, the best option you can get today is Dolby Vision Profile 5, which is used by, for example, Netflix and other streamers. But on the one side, we have the content, but on another side, we have products and screens. So we have very capable content. And then on another side, we have different technologies, how we can reproduce this content. And you see that even if you compare these entry products like IPS panel and VA panel, you see significant dynamic range difference, because dynamic range is purely the contrast. So if the screen can reproduce only 1000 to 1, so it's pure SDR screen, whatever you will try to do, whatever you will get on the input. So, and then you have HDR experience either in a dark or bright way. All products we ship and then we pitch to you are coming with all HDR formats and accept these formats. But I want to really focus a bit on Dolby Vision and then settings we have in our product. So then we have 4. But what we see by our experience, most will use it in Dolby Vision IQ, because Dolby Vision IQ is sensing the light and then is moving between Dolby Vision Dark if you are in a dark room and then Dolby Vision Bright if you are in a very bright room. And on purpose, we are on this side of the building because behind we have very strong sun. So when we open windows, so you will see there won't be any loss on the picture performance. And on purpose, we do it for our beamer story, which we have in the room behind you. So there you will see everything and how it works. The last thing is Dolby Vision Game, which is also supported by us. You know that Dolby Vision Game works in a slightly different way because TV set is communicating with the source, with game console, and is sending information about peak brightness and also black level, and then is getting just pure PQ because then don't need to process it. So then another, I think, interesting slide for you, and then extremely complex, how to do Dolby Vision, and then how it is complicated, but anyway, it's doable. So then we start from the shooting. So if you look on the shooting, so the real world, when you look on the sun and then the darkest areas, you have more than 30 stops of dynamic range. Our eye can see only 12 statically, in a static way. So if you look on one area, I think in 4 degrees viewing angle, if I remember well, dynamically, if you move your eye, so then you will see 24, but not more. Then we come to editing. So you see, usually editing is done in float, and then during the editing, we can extract from this 15 stops we get from the camera much more during editing. And then we come to HDR grade, and then we have the final part, which is Dolby Vision, which is done for Netflix. Usually there are 4 trims inside, targeting different brightness and different products. And okay, in the first step, we can get also SDR, which we call pseudo HDR. Why pseudo HDR? Because it is already done by colorists, so it's not just SDR camera taking it. HDR10, HDR10 Plus, because if you look on HDR10 Plus internally, so then it is just, as I would call it, simplified version of Dolby Vision, which is not having all the information. Why I talk about this? Because we have our own Dolby Vision production for you. But then we will come to this point and then how we did it. So HDR10, HDR10 Plus, we get additional 9 luminance levels, and then we can do it per frame, per sequence. And the Dolby Vision, you see, we have much more settings to adapt and to adjust. And at the end, on the right side, there are many different ways how to put it on the screen. So what I said is just you see behind you, and then it's this one. So you just to fully understand the production, we did it in the beginning of May. So it's just done in this 5 formats. So we have it right now. It is available on YouTube. You will get the link. You will be able to play it back. It's also available with this kind of overlays. So then you immediately know how many needs are where, and then how to see it. You see that we even remake the watch story, and it's not super effect, special effect. It was done in reality, because then just I was using the watch and staying in front of the camera and trying to just put the reflection from the watch to the camera sensor. And you can do it, you can stop it, and so on. It was just graded in DaVinci Resolve in a way which can be done for the streaming. So you can also look on this analysis of the brightness, average brightness, and peak brightness, everything, all the complex cases. So in many cases, there is HDR is linked to Dolby Vision, but there is still some HDR10 content on the market. So we still continue to work on tone mapping and the way how tone mapping works with several settings available in this year products. We will also push them to last year products as a software update. So this will be available. You will be able to play with the settings and see how the settings works together with MMDL information. Then IMAX is also part of our product. So 2 products you will test come with IMAX. If you get IMAX settings, so then you will see it in IMAX. But technically, IMAX is not far different from movie mode, because what we do in movie mode for us is open version of filmmakers mode. Why we don't do filmmakers mode? Because of very high brightness and then sticking to 24 frames. And then we believe that especially on 75, 85, 98 inch, it might be really annoying for a user, because many of them never understand. They think that this is the best picture quality. But we believe that movie mode, where you can change and adapt everything, is the much better option for end user. So HDR is done. Quick look on calibration. So this is the design and the signal flow inside the TV set. How you get the signal from the front, when we process HDR, where we process, and then that we have to switch HDR, not only we, everyone, every product you test, have to switch HDR to power low, and then have to process it inside the TV set. We have our experts behind. Christian is able to answer all your questions, whatever question you have about this, so he will answer. As he mastered Kalman Ready, and then he will also show you how Kalman Ready, how it works, and then how it is done. So in terms of DDC, because why we say DDC, it's not only Kalman Ready, it's also compatible with other calibration software, and then there is ability to upload information over USB. You see that right now we support all these ways of calibration. Then 3D LUT is also part of the story if it is calibrated. So you see that it is movie mode, which is calibrated. And then the rollout should happen for this year and the past year products also soon. Why calibration is important? There are a lot of comparisons done, but then just on this one, very simple. So here is just wrong white point and then RGB balance. After addressing white point, we already solved many areas, but still with RGB balance, we can address more of them. And then we come very close to reference picture quality. How it works in SDR before and after, you see here. So before calibration and then after calibration, you see the result we get and you will be able to get. Then the same for Dolby Vision, you see here how it works. And then there were many publications that we have crushed blacks or crushed shadows in TCL TV sets in Dolby Vision. So you see that we are able to resolve this issue also with calibration. We cover picture quality, many subjects, so audio. This year with audio we bring DTS Virtual X. We do it because it helps to virtualize non-Dolby Atmos content or non-Dolby content. So if you have Netflix, so of course you will hear it in Atmos, virtualized Atmos this way, but Virtual X works in a very similar way. But we believe that in some areas, especially for 2.0 content, delivers a bit better virtualization. We continue to work on audio quality. You see how flat is our response curve. In the past, it was bell-shaped, and this flat response curve is for the TV set with down-firing speakers and woofer on the back.